Hey guys, welcome back. நான் என்ன பண்ணுறேன்னா LangGraph வந்து கற்றுக்கிட்டு இருக்கோம். உண்மையாக சொல்ல போனால் அதான் கைஸ் பண்ணுறோம். LangGraph தான் கற்றுக்கிட்டு இருக்கேன் கைஸ். நேற்று வந்து ஒரு இது ஃபுல்லாக முடித்தேன் கைஸ். இன்னைக்கு வந்து எதுவும் பண்ணலை. அகாடமி LangChain கெட்டிங் செட்டப். இது புது ஃபோல்டர் வந்து கிரியேட் பண்ணி வச்சிருந்தேன் கைஸ். நான் ஓப்பன் பண்ணுறேன்னா கட்டதான். ஓ ஷீட். ஓகே கைஸ். ஓகே கைஸ். எல்லா செட்டப் பண்ணிட்டோம். மாடியூல் 0 ஓப்பன் பண்ணுவோம். பண்ணிட்டு ஜூபிட்டர் நோட் புக்னு போட சொன்னாங்க. ஜூபிட்டர் நோட் புக். தலையிலேயே இந்த சாரி ஹெட்செட் வந்து தலையிலேயே வச்சிட்டு இருக்குது. என் காதல் நீ காதல் நீ வேறு எல்லாம் வேறும் வேஷம். ஒரே செகண்ட் சிஎன்வி செட் ஆயிருக்கா மட்டும். அரே யார் ஹவு மெனி டைம்ஸ் சைன் இன் பண்ண சொல்கிறேன். சிஎன்வி செட் ஆயிருக்கான்னு பார்த்துக்கிறேன். செட் ஆயிருக்கு கைஸ். ஓகே ஃபஸ்ட் ஆமாம் கைஸ், நம்ம என்ன பண்ணுவோம், நானும் கற்றுக்குறேன் அப்படியே உங்களுக்கு நான் சொல்லித்தரேன் கைஸ். ஸோ பேசிக்காக என்ன பண்ணுவோன்னா அப்படியே போகுமா. ஸோ பேசிக்காக என்ன பண்ணுவோன்னா ஏன் இது லோட் ஆகிட்டே இருக்கு. நீ காதலனா வேறு எல்லாம் வேறு வேஷம். கழுத்தில் அந்த ஹெட்செட்டை போட்டு கடுவாது கைஸ். ஓகே ஓப்பன் ஆகிட்டு நம்ம ஏற்கனவே வந்து இதெல்லாம் க்ரியேட் பண்ணி வச்சுருக்கோம். ஓகே கைஸ், ஏன் இவ்வளோ ஸ்லோவாக இருக்குது எனக்கு புரியல. ஸ்டில் சரி, இது எல்லாமே நான் பண்ணியிருப்பேன்னு நினைக்கிறேன். எதுக்கும் அதோட ரன் பண்ணிடுவோம். நீங்கள் என்ன பண்ண போகிறோம்னா பேசிக்கானது தான் பார்க்க போகிறோம்.
This is really because end users often expect agentic applications to remember previous interactions. A simple example is chatbots, of course, which need to recall previous messages in a conversation in order to be effective. And now LangGraph gives you a lot of control over memory in your application. In this module, we'll explore the concept of memory and show how to add persistence to your graph. First, we'll reinforce a few points in Module 1 about messages and their importance as graph state. We'll then acknowledge that message history can be long, resulting in very high token usage. And we'll discuss a few ways to manage message history to mitigate this problem. This can include filtering or trimming or summarization to condense long interactions into succinct summaries. Now, one of the most frequent questions we hear related to
வேறு எல்லாம் வேறும் வேஷம். as to expected structure and types. Okay, in this case, you have a dictionary that has certain keys. You still want to use dictionary instead of class. Okay, okay. இது புஷ் பண்ணிக்க லோக்கல்ல இருக்குல்ல, ஏன்னா நீ வந்து இவ பண்ணதெல்லாம் போயிடும், இதெல்லாம் அது மாற்றி விட்டுரும். இதை ஃபஸ்ட்டு ஒரு எப்போவுக்கு புஷ் பண்ணிக்க இந்த சேஞ்சஸ்லாம் புஷ் பண்ணிட்டு பண்ணு. ஆமாம் ஆமாம், அதெல்லாம் இதாகாது. And dictionary so keys and types. So type error. Okay, if it is an option key not required. Okay guys, இப்போ நம்ம வந்து graph state tension class. Node is just Python functions version state defined as above. Because state is a defined schema, each node can access key with this key. Each node returns a new value of this key. State key by default value returned by each value. Return graph state equal plus two 3. Edges connect nodes. Normal edges are used to add one to one. Route between node functions or logic. Hmm. ம். ஏ ம் ஓகே. சரி, நம்ம வந்து இந்த டூல் மெசேஜ் மட்டும் ஆட் பண்ணுறோம். OpenAI What is parallel? Great. ஒரு மணி நேரம் ஆயிட்டு கைஸ். இது என்ன டாப் ஃபேன்ஸ்னு வருது இப்போ கைஸ்? இது ஆக்டிவேட் ஆச்சு. எனக்கு அதுனே தெரியல கைஸ். பட் ஸ்டில் ஓகே. செயின் பார்த்தா ரவுட்ரு வாக்கில் ஏஜென்ட் பார்த்தோம். ஓகே கைஸ், இப்போ வந்து செயின் மட்டும் ரவுட்ரு மட்டும் பார்ப்போம். ஓகே, டூல் காலிங் எல்லாம் சார். ஸ்ட்ரெயிட் கிராஃப் வந்து எங்கேருந்து இம்போர்ட் பண்ணோன்னா கிராஃப்லேருந்து கிராஃப் வந்து ஓகே. கண்டிஷனல் எனர்ஜி தான் கைஸ் இங்கே ரவுட்டர்னு சொல்கிறாங்க. இது ஒன்றுமே இல்லை கைஸ். இப்போ அதே இதில் வந்து மெமரி எப்படி ஆட் பண்ணுறோம்? மெமரி ஒன்றும் இல்லை கைஸ், ஒரே லைன் தான். இது அப்படியே நம்மள்ட்ட இருக்குது, இதுவும் நம்மள்ட்ட இருக்குது. இதை மட்டும் எடுத்துப்போம். எடுத்துட்டு எல்லாமே சேம் தான் கைஸ். இங்கே எல்லாம் சேம் கொடுத்துருவாங்களா? மெமரி மட்டும் பாருங்கள். ஓகே, இப்போ மெமரி மல்டிப்ளை பை தட் பை டூனா அதுக்கு ஒன்றுமே தெரியாது கைஸ். மெமரினா ஒன்றும் இல்லை, இந்த கம்பைல் பண்ணுறப்ப இதை போட்டுடணும். அதையே ரன் பண்ணிக்கிறேன். இதான் கைஸ் வெரி சப்ப கைஸ், ஒன்றுமே இல்லை கைஸ்.
to incorporate. Memory is a central component in building agentic applications with a high-quality user experience. This is really because end users often expect agentic applications to remember previous interactions. A simple example is chatbots, of course, which need to recall previous messages in a conversation in order to be effective. And now LangGraph gives you a lot of control over memory in your application. In this module, we'll explore the concept of memory and show how to add persistence to your graph. First, we'll reinforce a few points in Module 1 about messages and their importance as graph state. We'll then acknowledge that message history can be long, resulting in very high token usage. And we'll discuss a few ways to manage message history to mitigate this problem. This can include filtering or trimming or summarization to condense long interactions into succinct summaries. Now, one of the most frequent questions we hear relates to incorporating different databases with agent memory. We'll show that LangGraph supports this easily, ranging from simple key value data stores that are in memory to external databases that are very popular, like Postgres or SQLite. By the end of this module, you'll have a comprehensive understanding of memory in LangGraph and how to implement persistence to enhance your agent's capabilities. Let's dive in. So in Module 1, we laid the foundations. We built up to an agent with memory that can act, for example, use tools. It can observe the output of those tool calls. It can reason about what to do next based upon tool call outputs. It can persist its state to enable long-running conversations. And we can even deploy it using LangGraph Cloud. So now we're going to go a little deeper into both state and memory in this second module. And first, let's talk a little bit more about your state schema. So when you define a LangGraph state graph, you specify a schema. The schema is just the structure and the types of the data the graph will use. So we've largely been using typedict, which is actually quite convenient and often recommended. Typedict is just a dictionary where the keys have specific type hints. Now, note that these are not actually enforced at runtime, but they're very flexible. So in this particular case, let's just create a new typedict state with name as string and mood as a literal that should be happy or sad, okay? And of course, we already showed a lot of this. So you can take your state and you can pass it directly into state graph, just like we saw before. So here's a graph with nodes 1, 2, and 3. And you can see we just have kind of a decide mood decision rule. And this is looking pretty similar to some things we've seen in the past. So we're going to start, we'll go to that first node. Then we're going to go to nodes 2 or 3 based on the conditional edge that decides the mood, okay? So we'll invoke it with a dict, because remember our state is, of course, typedict. Invoke it with a state, Lance. And we see Lance is mood happy. So that's a very simple invocation of this graph using typedict as our state, which we've seen previously. Now, it's worth noting that typedict is not the only way to establish schema for your graph. For example, Python data classes are another way to define structured data, and they offer a pretty nice, concise syntax for creating data classes. We can see that here. So again, name, string, mood, just like we saw before. We only modify the graph slightly. In this particular case, instead of state name to get it from dict, in this case, we just do .name to get it from a data class. So very minor difference in terms of how we actually access values from the object, but that's pretty simple. Now let's go ahead and run it. There it is, just like before. And now we just pass a data class in, and this runs. Cool, runs just like before, so that's pretty nice. Now one of the problems with both data classes and typedicts that we've been working with is that the type hints are not actually enforced at runtime. So you can potentially assign an invalid value without raising an error. So let's actually show this. Remember we defined data class, and that mood we set as a literal, and the type hint said, hey, this should be happy or sad. But let's go ahead and assign it mad. No error. So that's an issue. Of course, type checkers will catch it, but at runtime we won't. So Pydantic is a really nice way to deal with this problem. It provides data validation, and it's quite popular. So let's define our state using Pydantic. You can see that here. Name is a string, mood is again a literal, but we can provide this validator on mood that actually confirms that mood is happy or sad, otherwise it throws an error. So let's then try to create an object, John Doe, mood mad, and what happens? Good, we get this validation error. Only happy or sad is permitted. So that's really nice. And of course we can supply this to LangGraph as state. There we go, just like before. And let's try to pass an invalid value for mood. There we go, we get our error, just as expected. And sad works, as expected. We get our error. Mood to pass an invalid value for mood. There we go. We valid just LangGraph as state. There we go, just like before. And let's try to pass. So that's really nice. And of course, we can supply this to LangGraph as state. There we go, just like before. And let's try to pass an invalid value for mood. There we go. We get our error, just as expected. And sad work. The type hints are not actually enforced. Now, it's worth noting that typedict is not the only way to establish schema for your graph. For example, Python data flexible. So in this particular case, let's just try create a new type dict state with name a string and mood as a literal that should be happy or sad. Okay. And of course, we already showed a lot of this. So you can take your state and you can pass it directly into state graph, just like we saw before. So here's a graph with nodes 1, 2, and 3. And you can see we just have kind of a decide mood decision rule. And this is looking pretty similar to some things we've seen in the past. So we're going to start. We'll go to that first node. Then we're state is, of course, type dict. And sad works. So we can see in particular, Pydantica is nice if we want to apply validation to any of the keys in our state. So in Module 1, we laid the foundations. We built up to an agent with memory that can act, for example, use tools. It can observe the output of. We covered a few different ways to define LangGraph state schema, including type dicts, Pydantic objects, or data classes. Now we're going to dive into reducers, which specify how state updates are performed on specific keys or channels in your schema. So let's go ahead and use type dict as our state schema to start. Here we go. We'll have a simple graph with one node. Cool, there we are. Invoke it. And we can see we return foo of 2, we pass foo of 1. That's because in our single node, we basically increment the value of foo by 1. Super simple example. Now let's actually think about this a little bit more. We look at what we input, we look at what we output. And you can see in the node, all we're doing is basically overwriting the value of foo with foo plus 1. Now, this is actually kind of an interesting point. By default, LangGraph doesn't actually know the preferred way to update the state. So by default, it just overwrites the values. You can see the final state of the graph is just 2 because we've overwritten 1 with our update that's performed here. So that's just an interesting thing to note, that when you define your schema, by default, when you make updates, you're going to overwrite the prior value in this particular state key or channel. Now let's look at a simple case of branching. Start, node 1 goes to node 2, node 1 goes to node 3, they both go to end, okay? Now, let's go ahead and try to invoke that, just like we saw before, and I'm going to do something interesting here. I'm going to try to catch invalid update errors if they occur. So basically, you see here, invalid update error occurred at key foo, can receive only one value per step, use an annotated key to handle multiple values. Now think about this, is kind of interesting. We talked a little about steps previously. These two nodes, 2 and 3, run in parallel, so actually they're part of the same step. Now let's think about what's happening. If I go to those two nodes, what I'm doing is I'm actually updating that same foo state key in both of them. I'm trying to increment the value of foo by 1. But you can see this causes a problem. If I'm incrementing that same shared state key in both places at the same time, it's ambiguous as to which one I keep, right? So that is actually the reason we get this invalid update error. It can only receive one update per step. If you try to make simultaneous updates to the same key in the same step, it's ambiguous by default because you're overriding the value with two different nodes at the same time. Now this is where reducers come into play. Reducers give us a general way to address this problem and other problems because they allow us to specify how to perform state updates. Now all we need to do, when we define our state schema, just like this, we just need to supply this annotated type to our key and include a reducer function. In this case, we use operator add function from Python's built-in operator module. This, when applied to lists, this will just perform a list concatenation. So what we can do is, we can say our state key or channel foo is a list of ints, and we're going to concatenate values to that as we proceed through our graph. So let's go ahead and try this with a single node. In this particular case, I'm just going to take whatever is in foo, and I'm going to go ahead.
டிஜிட்டு அது கவர்மெண்ட் ஆப்டா, அதில் ஏற்றி வச்சுக்க சொல்லுங்கடா. என்னது டிஜிலாக்கர் ஆப் ஏற்றி பாரு.
wait, just lock your phone and press right here to scroll through the selected glyph toys. They're even opening up this glyph matrix to developers with their SDK. So the community can develop fun games as well. For an example, spin the bottle, rock, paper, scissors. What do you guys think? Would you actually use this? Wait.
Different interesting buttons on the Nothing Headphones one. First of all, this top button here is actually also a slider, kind of like a mouse scroll wheel. So it's smooth, it goes back and forth, and it's volume up and down. You can also press it in once to play pause, and then hold it down.
Make sure you follow for
What the?
ahead and increment that by 1. And basically update that as a new list. And let's see what happens here. I run it. Now you can see 1, 2. I don't actually overwrite the value of 1 in this node, but rather I increment the list, or I append a new value to the list, which is 2. That's it. So because our key foo now has this reducer function, it knows how to handle state updates. In this particular case, because the state key is a list, it will basically just append values to my list. Now let's go ahead and look at an example graph with 3 different nodes, and build this out. Same as before. We're going to do branching just like we saw previously. And let's go ahead and run this. There we go. No problem. So you can see now this has no issue running, because in each of these nodes I'm just appending the value in that node to this foo list. Foo has a reducer function, as we defined right here, which will just append values to our list foo as we proceed through the nodes. Therefore, it's no problem to go ahead and update that simultaneously in the same step. So that's how reducers are extremely useful and actually critical in case
டெஸ்ட் மோட் இருக்குது
where you have branching and need to perform state updates simultaneously in multiple nodes within one step. Now I want to show kind of an interesting exception here. What happens if I pass none to foo? I catch the error here, and you can see you can't do concatenation between list and none type, right? So you can have certain cases where the input value in this particular case is invalid, given our current reducer. Now this motivates the need. Sometimes we want actually to find custom reducers to handle particular types of updates. In this particular case, an edge case around handling null inputs, okay? So what we can do is we can just define an arbitrary function that handles safely combining multiple lists, and we can just simply use that as our reducer. I'm going to define this class custom reducer state to show the one that's using our custom reducer. Let's try this out. So if I just use my default reducer state and I do what I just did, we get our error, just like we saw before. Now let's try my custom reducer state. You see it works. So even though we pass in none, it can handle that without a problem. And in our node, we go ahead and we append 2 to our list. So again, just a very simple example of how you can use a custom reducer to handle interesting cases. In this particular instance, our graph can't by default handle null values passed in, and so we have a reducer that allows us to handle such cases. Now in module 1, we showed a bit about using add messages to handle messages in state. And we also showed that the messages state is a useful shortcut to work with messages. It has a built-in messages key and has a built-in add messages reducer. So let me show you 2 examples that are actually equivalent. If I want to, I can always...
Hey. Hello? Okay. Okay. Discard, bro. Discard all. Discard all and paste. No, again you can update. Just copy the env file, keep it somewhere, then discard, then paste it. While pushing you can paste it. Put it in notepad or something. No. We have latest code changes everything in the other repo, right? You already copied. Yeah. You already did. Then you can push the code, right? You have to do stage. You already copy pasted. Why views not coming in the changes? Features. Can you send me the photo of the file? Open the file. Show me what are the folders are there. The POS features. Everything should be there. Yeah. Is it there? Is it there? Okay. If it's there, you are in. Bro, this one you send. Bro, what you send the screenshot of? This is my repo. Yeah, you send my repo only. Bro, this is my repo only. You send a screenshot of my repo. Yeah. Open the company repo and see. Okay. Bro, it won't be like that, right? Why it would show? Can you join Zoom? I'll check 1 second. காதலே காதல நான் வேறு எல்லாம் வெறும் வேஷம்.
See this your folder is there, right? I said. So this is ITS project backend is yours. This code I copy to here. This is our company. Hmm. This ITS backend. So this ITS backend you see here. Wait, it is come. This one only now, which I've showed you screenshot. Yes. Yeah, folders that file copied, right? Okay. Again, we'll. This one also we need to ignore. This one that's why I got confused. This is previous, huh? Oh, yeah. You have done some control that does something work. Com company repo we need to clone again, right? Yeah, I need to ignore that .git file, right? .git file and VNF file. Oh, sure. No, yes. We'll create a folder with that. Same, I tell that. Okay. Direct clone, that one. Initialize, we no need to do. No. Mm-hmm. It is Pure backend. Okay. Copy folders that yours. Bro, we have changed so many things. We are taking from there. From here, we have changed so many things, right? Uh, no, in code. Okay. You have done changes in the repo only. This manage data business out no need. No need that zip file I made. Yeah, I can do it. No, yes, yes. That Git and VNV I ignored, but I didn't find that Git. It is there. That is only one mistake. VNV, yes. Um, okay, my things okay. And in test, your mail ID is there in my mail ID there. Why this? Okay, the dummy screenshot. Huh? PAN card is for separate folder, huh? Like to check all the images. Yeah. Hmm. So much things you added. So br- no, now only you copied from same folders, right? So why again now it came for us this changes in this PAN card, this folders. Yes, this uh, this only you copied, right? This all folders. That uh, so PAN card is there here. So it's no need. Yeah, that's one. Cloud again. Yes, to store the image. Okay. I here are some your email ID is there. Right. I changed mine. Okay. My branch. Mm. Already that I have code is there in my branch, right? Like in my company repo you're saying. No, it will not go to main. So we are moving to direct main only, right? After my branch only. Right here my branch is here directly. Yeah, that. So wait, now doing any stage changes all or testing? We have need to stage stage all changes and the following path are one dot get ignore file. Customers open source sync changes. So Now it went to my branch, right? It is loading it. Hmm. Create pull. Ah, yes, yes. Create pull request. Merge pull request. Uh-huh. Yeah, yeah, okay, okay. Same APIs are coming or that I will test it. That REST app, something JW, something that models, all models will come right now. We have to install that one. Same I have done previously. ENV, EV type. This it is coming like this. This one I save it. Mm, one more thing, models also you need to install that. Uh, mm, no, no, this one. I have done. I installed settings update also so many things. Uh, at that time I got error. So fixed from ChatGPT. In setting ITSDB only is error on switch. Okay, okay, okay. The modified. Mm, mm, yes. Now make migration undo. Now we have modified something, right? Again, need to commit or like, no need to. You do run server once. This you install this one REST framework simple JVT. This one model pip installer. That one you do. That one you do. Now it will come. You add or you do once run server. Separate bro. That one not install pip installer. Mm, this one. Separate we have to do. That one second, one second. This one I will take it from that one. ChatGPT that it will give that too. One second. Yes, it is there. Rest some and rest hyphen. This one. Hmm. Django rest simple JST. Front end will take this call again. This will come. So once fix it, like Django. That one we need to take. PK. This one you in requirements keep it. Mm-hmm. PK. This one also I have done same. Pip something it is there. Pip pkg. Paste it. Not coming then. You didn't copy it, I think so. Hmm. This setup tool will come now. We need to do, bro. That yes, that one only. Yes or no? Next, bro. One. Ah, yes, copied. And this one will not come again, right? This one, Django REST one. And okay. And after this setup tool, this one is there. Setup tool, verify it worked. Still not working. Upgrade. Pip install setup tool. Okay, okay. Now install. That is business. What is this one? Column is active or business. No, we used for last 2 days that only ITS one. It is working that only. Again, it confuses me. Will be getting more confusion. Requirements. Make migration only. Business migrate we have to do. Yes. The project may not be business. Migration part delete. Again, it will once reload it. This page Java. Only business you are doing. Like no need to do. One dependencies. Dependencies not exist very much. Data also will delete in database that users and the no, right? Data will delete. business users. Bro, that is a project. That is not ours. We are implementing not here, right? You deleted wrong folder. No, we are into ITS POS backend. But in that you deleted again, that will get conflict again. Hmm. No, this is not new. This is new one. ITS POS backend. This is new one, company one. We are trying to do. Now you deleted, right? Pasted requirements. Requirements saved, which you are ये लाइट का सिंह हाल देगा पापा आ गए ಒಳ್ಳೆ ಸಂತೋಷ. What's happening? Done now. Where is the issue, bro? That one? Old files. It is. Please. Hmm. In that, in your folder, that one will work right now, or you'll execute that code also? Any changes? That you in that also you have deleted, right? Again, copy pasted. Here. Okay. I'll test this one also. And now working, right? Once test. Okay, okay. Fixed my question. Testing means again, I am not, wait. I am not going to test each and everything. That mail one, mail which I told you, that one. You finish that, I need to, I will push. Already I have sent to front-end team that API document and this code. So that's why I'm pushing. And this item list, that all new orders. Okay, the same bulk. Okay, it is coming. Okay, this only. Okay, that email is there. Okay, and let them start integration. What are the errors will come that we'll see. Hmm. And one more new document they are released. Okay, once have a look what you are getting understanding or not. The document is this one which I have sent you. Others of next PS only customer and coupons we already have done, bro. Customer, yeah, send us just now only this one. Yeah, this other options doc. Okay. Okay. I will test it and I will do this one. This commit changes, merge pull request. Okay. Bro, one more thing. Now it is this one is here, right? This is my branch, and this is one like another personal branch. Okay. If I need to take pull request from her branch, if I need to take this code to my branch, so what are the functions we have to take pull request or what we have to do? You got my question, right? No, no. Yeah. So if I need her code, so she didn't push till now. So this is our code only till now. And I need, in suppose she pushed code, I need her code uh, in my repo, in my branch. Branch, huh? Hmm. main. हाँ, अच्छा, pull from main. Pull from main as we are doing the same. It imposed, she had, bro, where is that one? This one only, yeah? That, right. Merge folder. Okay. Okay. I will once check it and I will do it. Okay. Once check it that, once you finish it. Okay.